All right, so for example number 4, it's a little more clear why this is part of our calculus work. Example 4 says, at the beginning of the summer, the population of a hive of hornets is growing at a rate proportional to the population. From the population of 10 on May 1st, number of hornets grows to 50 in 30 days. If the growth continues to follow the same model, how many days after May 1st will the population reach 100? Okay, and so for example number 4, they give us some information and then we got to solve from there. So the rate of change is proportional to the population. So dy dt, and we're assuming that y represents the population and that t represents the time, is equal to some variable or constant k times the population y. Okay? And so here we could do differential, we could do a separable differential equation and then integrate the two and solve for y. And when we do that, you get when you do that, you get this y is equal to y naught, the original amount. And we could, depending on whatever information they gave us, we could say some sort of rate of change, right, raised by a constant or higher or base or whatever. So here's how we determine the base. So it's usually some sort of base. We've said e, we said 1 plus the rate and all that stuff. And then it could be raised to some variation of kt up here. Okay. So what they tell us is that you started with 10. So the initial amount, y naught, is equal to 10. And then it goes as high as 50 in 30 days. So you have 50 in 30 days. Okay? And so the growth is exponential because it's proportional to the population. And then it grows by a factor of 5 in 10 days. Right? Or no, by a factor of 5 in 30 days. So, in other words, 10 times 5 equals 50 in 30 days. So we have this cycle that after 50 days it gets multiplied by 5. Or after 30 days it gets multiplied by 5. In other words, we started with 10. Sometimes if you write it in tabular form, it's a little easier to see. So I've got y and t. So on the first day, we had 10. I wrote that in the wrong thing. On the first day, day 1, we had 10. And then on day 30, we had 50. So to get from here to here, we multiplied by 5. Well, that's exponential growth. And so that means that my base b is probably going to be 5. Okay? Because that's what we go by. Well, how long does that take? Well, once every 30 days. So we could write k as 1 over 30. Okay? 1 over 30. And so with all that information, I could probably proceed and solve for t. So how would I solve for t? Well, the question wants us, if we think of it in terms of this, y equals y naught times y is equal to b, our base, right? Let's write it this way. Y naught, our base, which is 5, raised to the 1 over 30 times t. Because after 30 days, we would get one cycle. That's where the 1 out of 30 comes from. So what did we start with? Well, we started with 10, right? times 5 raised to the 1 over 30 times t. And what we want to end up with is 100. Because that's what the question is. How much time goes by before you get to 100? All right. So now for this is just pretty much pre-calculus. If I divide both sides by 10, I get 10 is equal to 5 raised to the 1 over 30 times t. Well, I don't like t being in the power of base 5. So I'm going to take the natural log of both sides. Now, the property of natural logs will allow me to take this exponent and toss it to the front. So I've got the natural log of 10 is equal to 1 over 30 times t, natural log of 5. And I want to solve for t. So what I'm going to do is I'm going to multiply everything by 30. Okay? So I get 30 times the natural log of 10, and that will cancel this 1 over 30, is equal to t times the natural log of 5. I'm going to divide everything by the natural log of 5, and I get 30 times the natural log of 10 all over the natural log of 5 is equal to t. And you can do some cleaning up, I guess, with the natural log stuff if you want to. Or you could just leave it like that. But if you plug that in your calculator, you end up with t is equal to 42.92. Whoops, I'm writing the answer. 42.9. So it's about 43 days. So just to recap what we did is the textbook says, look, there's some bees, and at the beginning of the summer, there were 10 bees. After 30 days, there were 50. How long will it be before you get 100? Well, it will actually be about 43 days after the beginning of summer, okay? And then the population will reach 100. Any questions from anyone?